So today we're going to be having a hands-on presentation, and we're going to be seeing how Kong can run on Amazon ECS. But before we do that, I'm going to be giving a little bit of context on why that matters. We are seeing it all around us, and we're seeing it at this conference. We're seeing it in our organizations, that the way we're building software today, the way we connect it, the way we secure it, the way we test it, it's fundamentally different than even 5 years ago or 10 years ago. 2013 and 2014 were two very important years if you work in infrastructure, if you work in application development. In 2013, Docker was released, and in 2014, Kubernetes was released. And Docker, containers, and new ways of connecting applications and securing these apps, deploying them, has changed how our systems are looking now in production. We used to build software as large monolithic applications, and we moved away from that in order to be able to iterate faster, to innovate faster, to secure our applications in a better way. We're doing it because fundamentally, we want to be able to grow our business. We're moving, we want to be deploying more often, we want to be releasing products more faster. Therefore, we're going to be deploying our services in the cloud. We're going to be leveraging existing infrastructure that, we stand on the shoulders of giants. We want to be able to decentralize the architecture because at the end of the day, we want to improve the reliability of our applications with the existing customers. And we also want to attract new customers. We want to enter new regions. We want to enter new markets. We want to be able to launch new products. Therefore, we use the cloud. We deploy in multiple regions. We deploy all around the world to make that happen. In order to iterate that fast, we need to be able to have software and both software, infrastructure, but also the culture in the engineering team to be able to release faster, not once a year, not once a quarter, but every day. We're building for the cloud. We're becoming cloud native. We're taking advantage of what other organizations, AWS in this case, is offering us so that we can focus on what matters, the products, the customer, not on infrastructure. Data can be in three different states. Data can be in use. It can be in a data lake. It can be in a database. And we use it from our monolith. We use it from our applications. Or, for example, we run MapReduce jobs and we access the data at rest in the database, therefore, or in those data lakes. But starting from 2013 and 14, data is entering a new state. It's more and more in motion. It's in motion from one application to another, from one microservice to another, from one data center to another. And when data is in motion, there is something in between that makes our applications, could make our applications unreliable, and that's the network. We all know that the network is, by default, unreliable, unsecure. The network can slow down. And when that happens, the application also slows down. And when that happens, the end user is not happy about it. The application is down. Back in the days when the monolith was down, the end user experience was not good. Today, when the architecture is slow, the application is down. Slow is the new down. We're going to be seeing 40x increase by the end of 2020 of data in motion. We're going to be having and collecting more information, and it's going to be in motion more and more the more decoupled and distributed our applications become. We're going to be investing more to make sure that that information in our services is as close as possible to the end user. Therefore, we're going to be building data centers, or perhaps AWS can do that for us. We're going to be investing into infrastructure that allows our software to run everywhere. And we're getting smarter. We're seeing an exponential acceleration of computing power. It is estimated by 2025, there's going to be 1 trillion devices connected to the internet. Now imagine all of that data in motion. from the users, from our clothing, from our appliances to the internet. It is a lot. And we're seeing it. We're seeing every day. Every business is becoming a digital business in order to survive, in order to keep acquiring new customers, in order to keep attracting new users. And when they become digital, they become cloud native. We move to the data center, we move to the cloud, we leverage as much as we can so that we, the architects and the engineers, can focus on what matters, which is the end user, the end customer, the actual product we're building. Every transformation that we're seeing in technology should always be associated with a business goal. Even that being growing the business. And so we the architects, are working with the teams that are building these products, and we're providing them with the right infrastructure in place so that they can focus on doing that, do what they do best, while we create the underlying infrastructure. It's like running a city. We provide the streets, the bridges, the roads that the teams can use to build their products on top. But like a city, we need to be able to enable the flow of people from one building to another. We need to be able to provide electricity. We need to be able to provide security, police departments, fire departments, routing. We want to be able to redirect the flow of data from one place to another. Therefore, we need street lights, street signs. The more distributed we become, the more data in motion, the more network we push in between our systems, and the more infrastructure we need, like a city. Kong wants to help you and the architects into creating this city, into creating the building blocks of how these systems are going to be connected with each other, how they're going to be secured, how they're going to be documented. So we want to provide one grid which allows the developers and the engineers to create the APIs, focus on the business logic, and everything else is being taken care of. As we transition from traditional brownfield monolithic applications, we're also going to be, as part of the journey, we're going to be supporting different teams that are at different stages in that journey. So we're going to be having teams running monoliths. We're going to be having more progressive teams running microservices. We're going to be having teams running, for example, AWS Lambda, serverless. We're going to be having all sorts of things. And when we provide the infrastructure to the entire organization, we have to provide the infrastructure for each one of these teams and each one of these architectures. With Kong, it's an open source gateway. We are helping developers and architects to do exactly that. You can deploy Kong pretty much across the board, across each one of these architectures, and it enables those systems to communicate with each other in a secure way, in an observable way, so that the entire networking aspect is taken care of, the same way your entire infrastructure is taken care of by AWS. And you might have heard of the full life cycle. It's lots of words to say that, to mean that the kind of challenges we're going to be experiencing when connecting our systems, it's not necessarily going to be only impacting the runtime, the actual data planes of the processing of those requests, but it involves a full life cycle. It involves what happens before we create the API, we publish it online, and it involves dealing with what happens after. When we create APIs, the organization must be able to do it in an organized way. Most of the transformations that are happening at runtime in an enterprise organization are caused by miscoordination when creating the APIs in the first place. If the teams are not creating them in a consistent manner, then eventually they will be incompatible, and that involves later on those very complex and ugly transformations at runtime that we want to avoid. So how can we help the teams create APIs the right way? How we can help them run the right way? And then once we have all of these moving parts being deployed, how can we help the teams identify traffic patterns that are not necessarily, they're not accurate or not what they were expecting to be? And so the design phase, the mocking phase, the testing phase, manage, publish, the security of that, this is what the full life cycle means. It's everything from start to end. And so with Kong, we provide different products that can tackle each one of these different use cases. These are going to be required. Now, keeping Kong aside for a second, these stages are already being implemented today by your teams. The difference is, are they doing it the right way? Are they doing it in a standardized way? It's not a matter of, do we need this? The matter is how we're going to be implementing it. Today, each one of these phases is either done manually by the teams, or it's done in a poor way, or it's done by taking time away from building the actual final product, which is what they should be doing. Each one of these is challenges that have to be addressed. Kong, it's an implementation that tries to do that. I set a little bit of context here, but let's go a little bit into let's fire up the terminal. Let's look how Kong works and how we can deploy Kong on AWS ECS so that we can start protecting and securing the API that we publish on Amazon. So Aaron, I'd like to invite you here. Thank you.
Thank you, Marco. Right. So as Marco described, you can deploy Kong in a number of different instances. But in this particular case, we're using Kong to proxy traffic to a microservice, right? Something hosted in a container. So just looking at this deployment, there we go. All right, I'm not as loud as Marco, so here we go. All right, so in this particular case, we're using an auto-scaling group, right? We can set the number of availability zones, and we can, in each of these cases, kind of determine how Kong is going to be oriented towards an upstream, right? So you could use Kong with AWS Lambda, but in this particular case, say we want to point it at a container, right? Well, security is an important concern, as Marco described. And with AWS IAM roles, using a role is helping us move from this paradigm of having IP addresses and kind of fixed physical-based security that's set in a defined perimeter to something that's identity-based, right? Something that is more concerned with what something is rather than where it is or where it's from, right? So in this particular case, our upstream service will only take traffic from Kong based on Kong's role. And that role is inherited from ECS. Same thing goes for Lambda, right? Now, we still want to ensure redundant layers of security, right? We're still moving towards completely identity-based security. And in order to really define how these services go, we're going to use Aurora, right? Now, we could use Postgres. Kong works with Postgres or with Cassandra. But Aurora is really useful because you don't need to think too much about your deployment. You know, you can have this redundancy and fallback all throughout your system without really needing to think much about it. Right? It synchronously replicates across AZs, so all you really need to think about is how you connect, you know, your business logic at a top layer. You don't really need to think about the imperative details. And you may start to see a pattern with IAM roles, with Aurora. We're getting to a point where we can really just focus on what we want to build rather than how we're going to connect all the parts in between. So if I write to one Aurora node and the AZ suddenly goes down, Aurora really gives us this confidence that we can propagate those changes. And for Kong, that's incredibly important. You know, if you're an application developer, you've probably always thought of a database as the pot of gold at the end of the rainbow, right? This is why people are hitting your endpoints. But here, we're using Aurora as a prism, right? We're using it to define where our traffic is going. So we've discussed so far how Kong proxies this traffic. What we need to get into is why we want to have this middleman in the first place. What's the purpose other than just defining routes? Think back to what Marco said about how we have a city and how we need services in the city. We need plumbing, we need police forces. one really great use case for Kong is security. Another would be transformation, right? But what I want to show you today is rate limiting, right? In a city, you have people going down the freeways. If you go out on the Las Vegas Strip, you can probably see this right now. Cars are just going everywhere. It's crazy, right? You need to define a limit to how fast people are going. So think of this as your highway patrol. Okay? Kong has the ability to tally requests as they come through, and it can sync these with Redis. And in our particular case, we want to use Elasticache. And it can tally these requests and count up to a certain number of requests within a time frame. And if it exceeds that number, it will actually prevent that traffic from ever hitting the microservice in that time frame. And if you think about the advantage that provides at scale, that really prevents, say, one malicious consumer who's abusing the service from shutting down the service for everybody else, right? And in this particular case, I chose 21 as the number, because if you're playing blackjack and you exceed 21, you bust, right? So it will stop the request from ever hitting the service. So what we're starting to see is that AWS also provides performance efficiency for our move to microservices. It prevents us from needing to hit the database every time we get requests, and it provides a way to minimize memory competition. Right? So now that we start to see what's going on underneath, remember, we don't really need to worry about what's going on in each availability zone. We just have the top level logic to think about, and that's great for us as developers. But one really great thing about Elasticache in particular that you can't get just from running Redis is that when you hit a single Elasticache node, it actually warms the entire cluster, right? So this is completely invisible to the user, right? They think that they're just hitting one abstract point, but this could actually be divided across your entire region. Okay? So I want to really briefly show you rate limiting in action, and this is using Kong Studio, something that Marco mentioned earlier. So this is a great tool for just testing your services as you build them. And I'm not sure if it's playing. Let's see. There we go. Right, so you can see I'm continuously sending requests. It's building up. I can see the body and the status code at the very top, as well as the latency. And again, this could be going to any availability zone. We really don't have insight into that. And that's a good thing, right? We want this to be distributed. But now I've hit over 21 and gone bust. And Kong is preventing all of this traffic from hitting our service. So at a scale of, say, millions of requests, this could really protect our infrastructure, right? So what we've seen today is just a very limited use case. But what I challenge you to do right now is to download Kong, to try it for yourself, maybe use our cloud trial if you don't want to set up all the infrastructure, and see some of the ways that you can use it. I'm sure you'll find something that we didn't think about today, and we really want you to share that with us. And before we go, I want Marco to come up for some closing remarks.
Thank you, Aaron. So this was a very simple demonstration of what Kong can do on top of your APIs. Kong already comes out of the box with 70 plus plugins that can perform all sorts of things: authentication, authorization, traffic control, rate limiting, logging, transformations, and so on and so forth. We do rely on a data store to be able to store this configuration, like Aaron explained. So you can definitely use services like Aurora to forget about that. But you can also use Kong in front of your AWS Lambdas. And so it can protect and secure any sort of API, including serverless functions. When we think about a Lambda function, somebody has to invoke that function. And that something can be either a queue, if you're processing a queue, or can be a direct request. Therefore, the Lambda function at that point becomes very similar to an API endpoint. And like every other API endpoint we have, we want to secure them, monitor them, trace them, observe them, and so on. There is 3 or 4 different deployment methods available for Kong on AWS, including AMIs, including CloudFormation, including the official Amazon Linux RPM distribution. So like Aaron said, feel free to go ahead, download Kong. It's very simple to get up and running with it. And if you have any questions, you can meet us at our booth here in the expo area. Thank you.